Hello everyone, I am Bakash Adil, a software engineer and a PhD student in my first year in the University of Ibn Zahra Agadir. Today I will present my article in the topic of uh, sentiment analysis from text towards user-oriented adaptive system. Let's see our plan. First we have an introduction, then I'll talk about the text-based sentiment analysis. Then we will see some of the most powerful methods for text representation and learning algorithms. And then we will see some of the related works. And finally, a conclusion. So there are many forms of sentiment analysis, namely facial and speech recognition. But in this article, we are more focused on text-based sentiment analysis. This field of sentiment analysis is critical in many domains. In our case, we are interested in e-learning, as sentiment analysis can help us determine the emotional states of a student based on his comments uh, and his discussion, and then it can interact accordingly in order to motivate him to accomplish his courses. However, this task is very challenging as most of the time emotions are not expressed directly using words such as happy or sad. Therefore, sentiment affirmation could be extracted from context and the interpretation of meaning. The text-based sentiment analysis means extracting sentiments or emotional state based on comments or any textual data. As we see, there are two main steps to perform this task. The first one is the feature extractor or the text representation. As we know, learning algorithms are not capable of understanding words or sentences. Therefore, we have to convert them into digital data. And to do that, we use different natural language processing method. For the second step is the step of learning algorithms, which can be supervised or unsupervised methods. Let's see some of the most known and powerful text representation methods. First, we have one-hot encoding. This method represents each word into a two-dimensional vector of zeros, except for the position of the word itself, which has a value of 1. The word embedding is a method that is featured word level representation, which is capable of detecting the semantic meaning of words. It has two approaches, which are the opposites. The first one is continuous bag of words, which predicts the target word based on the surrounding words, and the skipgram, which predicts the surrounding words based on the target word. TF-IDF, or term frequency inverse document frequency, is a weighting method which is used to reweight vectors obtained by all other methods based on the frequency of each token. It evaluates how relevant is a word to a document. And for the learning algorithms, we have two major groups: the supervised learning, which used on labeled data, and the unsupervised learning, which are used on the unlabeled data. For the supervised learning, we have machine learning, such as logistic or linear regression, SVMs, etc. And we have deep learning, such as CNN, LSTM, BiLSTM, etc. And for the unsupervised learning, we have clustering using k-means or association using a priori algorithm. Now let's see some of the related work. This first study, after pre-processing each sentence and getting the NEVA words. The NEVA words means noun, adverb, verb, and adjective. An emotion vector is calculated for each affect word by computing the semantic relatedness score, then performing a phrase level analysis by using context to adjust the pre-calculated vector, and finally aggregating the emotion vectors of all affect words in order to have an emotion label for the sentence. For this second study, after obtaining the word representation based on word embedding and TF-IDF, this representation is then fed to a bi-LSTM mechanism, and then we obtain a document representation, which is then fed into a feed-forward neural network classifier to obtain the sentiment label of the sentence. For this last method, each word is represented using word embedding, and then this representation is fed into a bi-LSTM to learn the hidden states, and then attention mechanism is used to detect words that contribute to the meaning of the sentence. And after detecting the final sentence representation, it is then fed into a multiple binary logistic regression, and then using argmax so we can have the emotional label of the sentence. And now let's give some perspective for these methods. For the first method, it showed a very powerful performance, and it outperformed many other concurrent methods. And I think that the context of each word is critical in this field of study, as we cannot understand the emotional state of a word without having the whole context of the sentence. For the second study, it also reached a very high precision rates, which is over 91%, and it outperformed other known approaches. I think for this method, we can test other machine or deep learning algorithms instead of simple feed-forward network, as we can see here. They only used a feed-forward neural network with one hidden layer. We can use two hidden layers or other deep learning approaches, and we can compare the results. And for the last method, it also showed a very powerful performance compared to many other approaches. And personally, I think that the concept of using multiple logistic regression functions can improve the overall performance. To conclude, we have reviewed some of the most powerful techniques to extract sentiments from textual data, starting from text representation or feature extracting to the learning models that predict the emotional state of text. And now for my future work, based on all the related work I've seen, I think I will try to come up with my own proposed method, test it on different databases or datasets, and compare the results, and then try to improve it so it can reach a good performance in the task of sentiment analysis. And here is the bibliography of the three mentioned studies. And thank you for your attention and your time.